Welcome, dear listener. Settle in and let your mind drift. Tonight, we're embarking on a journey, a voyage through time, across billions of years. We're going to explore the story of our home, planet Earth. It's a tale of fire and ice, of life and death, and of the incredible forces that have shaped the world we know today. Forget, for a moment, the hustle and bustle of modern life. Let's simply marvel at the grandeur of our planet's history. This is the journey of Earth. Our journey doesn't begin on the familiar ground beneath our feet, but in the vast, almost unimaginable expanse of space about 4.6 billion years ago. To grasp that immense span of time, consider this. If you were to count one number every single second, non-stop, it would take you over 145 years to reach 4.6 billion. Now imagine a colossal cloud, a swirling nebula, a cosmic nursery, far larger than any earthly landscape. This wasn't just any cloud. It was a celestial recycling depot filled with the stardust of ancient stars. These weren't just any stars either. They were giants, some far larger than our sun, which had lived out their fiery lives and, in their dramatic deaths, scattered their elemental treasures across the cosmos. Think of it as a grand cosmic kitchen. These ancient stars had forged elements like carbon, iron, and oxygen, the very building blocks of our planet and of life itself, through the incredible power of nuclear fusion. When these stars reached the end of their lives, they exploded in spectacular supernovae, scattering these elements like seeds across the universe, creating the rich cosmic dust that formed our nebula. Scientists have peered into these nebulae using powerful telescopes like the Hubble and James Webb Space Telescopes. They've captured breathtaking images of these swirling clouds, often glowing with vibrant colors, revealing the active star formation within. One particularly famous nebula, the Eagle Nebula, harbors the pillars of creation, towering columns of gas and dust, where new stars are being born even today. These images aren't just beautiful. They provide crucial evidence for our understanding of how our solar system and others came to be. Now picture this. Gravity, the unseen sculptor, began to work its magic on our nebula. It started pulling the gas and dust together, causing the cloud to spin faster and faster, like an ice skater pulling in their arms to spin more rapidly. As the cloud collapsed, the center grew hotter and denser, fueled by the accumulating mass and the friction of the collapsing material. This process continued until, finally, nuclear fusion ignited, and a fiery infant was born, our sun. This newborn sun, a blazing ball of hydrogen and helium, began to emit light and heat, clearing away the surrounding gas and dust with its powerful solar winds. But not everything was pulled into the sun. The leftover material formed a spinning disk, a vast flat plane of gas and dust orbiting the young star. Imagine this disk as a cosmic dance floor, where particles were constantly colliding and sticking together, like dancers coming together and separating. This was the stage upon which our Earth and all the other planets would soon take shape. Then, a dramatic event, a cosmic ballet of destruction and creation, changed everything. A Mars-sized object named Thalia, a rogue planetesimal, was on a collision course with the young Earth. Imagine a world where the sky was filled with the looming presence of this approaching giant. Scientists believe Philae formed in a similar region of the solar system as Earth, but its orbit became unstable. This instability sent it hurtling towards our planet. The impact wasn't a gentle nudge. It was a cataclysmic collision, a titanic smash that reshaped the very core of our world. Computer simulations, incredibly detailed and complex, have allowed researchers to recreate this event. These simulations show that Philae didn't just graze Earth, it struck a glancing blow, a powerful impact that sent both bodies partially melting and merging. This wasn't a clean collision, but a messy, chaotic interaction. The force of the impact was so immense that it vaporized vast amounts of rock and metal, creating a swirling cloud of debris. This cloud of debris, a cosmic spray of molten rock and metal, was flung into space, orbiting the newly reformed Earth. Over time, gravity, the patient sculptor, began to pull this debris together. It wasn't a rapid process, but a gradual accumulation, a slow dance of particles coalescing into a single body. This body, our moon, emerged from the wreckage of this cosmic collision. The moon, more than just a beautiful nightlight, played a crucial role in stabilizing Earth's rotation. Without the moon's gravitational pull, Earth's axis would wobble significantly, leading to wild and unpredictable climate swings. Imagine seasons changing drastically every few years, or even every few months. The moon's stabilizing influence allowed for a more consistent and predictable climate, a crucial factor for the development of life. Interestingly, samples brought back from the moon by the Apollo missions have provided evidence supporting the impact theory. The isotopic composition of lunar rocks is remarkably similar to that of Earth's mantle, suggesting they originated from the same source. This similarity is a powerful piece of evidence, a tangible link to that ancient collision. It's a testament to how even violent events that might seem purely destructive, can lead to balance and beauty. The collision with Theria, a cosmic catastrophe, ultimately gave us the moon, a celestial companion that has profoundly shaped the history of our planet. It's a reminder that even in the chaos of the cosmos, there's a delicate balance, a hidden order that allows for the emergence of worlds and the possibility of life. Over vast stretches of time, the molten Earth began its slow, arduous process of cooling. The intense heat generated by the planet's formation and the radioactive decay within its core gradually dissipated into space. The fiery sea of magma began to solidify, forming a thin, fragile crust. Imagine this crust as a delicate skin, forming over a still hot, churning interior. However, this wasn't a uniform process. Volcanoes still erupted with tremendous force, spewing molten rock and releasing vast quantities of gases into the atmosphere. These gases, water vapor, carbon dioxide, nitrogen, and sulfur compounds, formed the early atmosphere, a starkly different composition from the air we breathe today. Scientists believe that this early atmosphere was incredibly dense, creating a greenhouse effect that trapped heat and kept the surface relatively warm, even as the planet cooled. This greenhouse effect also played a crucial role in another significant event, the condensation of water vapor. As the atmosphere cooled further, the immense amount of water vapor began to condense, forming clouds. And then, the rain began. Not just a gentle drizzle, but a torrential downpour that lasted for millennia. Imagine the sheer volume of water falling from the sky, a relentless deluge that reshaped the landscape. This constant rain filled the low-lying areas of the newly formed crust, creating the first oceans. These weren't the clear blue oceans we know today. They were likely murky, acidic, and incredibly hot, but they were the beginning of something extraordinary. These oceans, vast and deep, would become the cradle of life, the birthplace of all living things. Think about the sheer scale of this transformation. Imagine the steam rising from the still hot surface, a thick, swirling mist that obscured the horizon. Envision the constant rain, a deafening roar that echoed across the barren landscape. Picture the gradual calming of the planet, the fading of the fiery glow as the surface solidified and the oceans filled. Geologists have found evidence of these ancient oceans in the form of pillow lavas, volcanic rocks formed underwater, preserved in ancient formations. These pillow lavas are like fossilized snapshots, capturing the moment when molten rock met the primordial sea. It's a testament to the resilience of our planet, its ability to transform from a fiery inferno to a water-rich world. The cooling of the molten earth and the formation of the oceans were pivotal moments, setting the stage for the emergence of life, the next chapter in Earth's extraordinary journey. Over eons, the molten earth began its slow, deliberate cooling. It was a gradual process, like a blacksmith's forge, slowly losing its heat. The fiery sea of magma, once a constant, began to yield, solidifying into a thin, rocky crust. Think of it as a delicate, newly formed skin stretched across a still hot core. However, this crust wasn't a static shield. It was a dynamic, restless surface, constantly reshaped by volcanic activity. Volcanoes, like fiery vents, still erupted with tremendous force, spewing molten rock and releasing vast plumes of gases into the atmosphere. These gases, water vapor, carbon dioxide, nitrogen, and sulfur compounds, formed the early atmosphere, a stark contrast to the breathable air we know today. Scientists have pieced together this early atmospheric composition by studying ancient rocks and trapped air bubbles within them. For instance, tiny inclusions of gas found in ancient zircon crystals, some of the oldest minerals on Earth, provide direct evidence of the atmosphere's composition billions of years ago. These tiny time capsules reveal a world where the air was thick, steamy, and rich in carbon dioxide. As the planet continued to cool, a remarkable transformation began. The immense amount of water vapor in the atmosphere started to condense, forming dense clouds that blanketed the sky. Then, the rain began. Not just a passing shower, but a relentless torrential downpour that lasted for millennia. Imagine the sheer volume of water cascading from the sky, a continuous deluge that sculpted the landscape and filled the low-lying areas. This epic rainfall created the first oceans. These weren't the tranquil, blue expanses we see today. They were likely murky, acidic, and incredibly hot, but they were the genesis of life. Think of them as a primordial soup, a rich broth of dissolved minerals and gases, where the first sparks of life would ignite. Deep-sea hydrothermal vents, like those found in the modern ocean, likely played a crucial role in this process. These vents, where superheated water erupts from the ocean floor, would have released minerals and chemicals, creating environments conducive to the formation of complex organic molecules. Scientists have even discovered ancient microbial fossils near these types of formations, suggesting life might have originated in these extreme environments. Picture the scene: steam rising from the still hot surface, a thick swirling mist that obscured the horizon. Envision the constant rain, a deafening roar that echoed across the barren landscape. Imagine the gradual calming of the planet, the fading of the fiery glow as the surface solidified and the oceans filled. It was a monumental shift, a transition from a chaotic, fiery world to a water-rich planet, ready to embrace the dawn of life. In these primordial oceans, these ancient, churning seas, life began its extraordinary journey. It wasn't a grand entrance, but a quiet, almost imperceptible emergence. Simple, single-celled organisms, the pioneers of life, appeared. They were microscopic, invisible to the naked eye, but their impact on our planet would be nothing short of monumental. These early life forms, called prokaryotes, were remarkably resilient. They thrived in environments that would be lethal to most modern organisms, drawing energy from chemicals and heat vents deep within the ocean. Imagine these tiny beings, the first inhabitants of Earth, living in a world completely different from our own. One of the most significant breakthroughs in early life was the development of photosynthesis. Some prokaryotes, known as cyanobacteria, learned to harness the sun's energy, using it to convert carbon dioxide and water into food. This process, photosynthesis, released oxygen as a byproduct. This was a game changer, a turning point in Earth's history. Scientists have found fossilized evidence of these ancient cyanobacteria in structures called stromatolites. These stromatolites, layered mounds of sediment formed by microbial mats, are like living fossils, providing a tangible link to the earliest life forms on Earth. Some stromatolites still exist today in places like Shark Bay, Australia, offering a glimpse into the ancient past. Think about the sheer scale of this transformation. These tiny organisms, through their collective activity, gradually began to change the composition of Earth's atmosphere. Oxygen, once a rare gas, began to accumulate, slowly transforming the planet. It was a gradual process, a slow and steady breath of life into our world. This increase in oxygen had profound consequences. It paved the way for the evolution of more complex life forms, organisms that could use oxygen to generate energy more efficiently. It was like unlocking a new energy source, allowing life to diversify and flourish. Researchers have used isotopic analysis of ancient rocks to trace the rise of oxygen in Earth's atmosphere. These analyses show a gradual increase in oxygen levels over billions of years, punctuated by periods of rapid change. One such period, known as the Great Oxidation Event, occurred around 2.4 billion years ago, marking a significant turning point in Earth's history. It's a story of resilience, of adaptation, and of the incredible power of life to transform its environment. These simple single-celled organisms, the pioneers of life, laid the foundation for everything that followed, from the dinosaurs to the trees to us. They were the architects of our world, shaping the planet we call home. As oxygen levels continued their steady climb, the stage was set for an extraordinary leap in the story of life. The planet was primed for diversification. Multicellular organisms, once a rarity, began to evolve in earnest, leading to an explosion of new forms and functions. Imagine a world where simple, squishy creatures were giving way to complex, structured beings. It was a revolution, a biological renaissance. This period of rapid diversification culminated in what scientists call the Cambrian explosion, around 541 million years ago. It wasn't an explosion in the literal sense, like a supernova, but a rapid diversification of life forms, a burst of evolutionary creativity. The oceans, once home to relatively simple life, now teemed with an astonishing array of creatures. Many of these new organisms developed hard shells, skeletons, and complex sensory organs. It was as if evolution had suddenly discovered a treasure trove of new designs. One of the most fascinating creatures to emerge during this time was Anomalocaris, a large predatory arthropod with grasping appendages and a circular mouth. Imagine a creature with a segmented body, large compound eyes, and a terrifying ability to capture its prey. Hallucigenia, another bizarre Cambrian creature, looked like something out of a dream, with long spindly legs and protective spines. Its true nature was a mystery for years, until scientists finally figured out which end was up. The Burgess Shale, a fossil site in Canada, has provided an invaluable window into this period. The fossils found there are incredibly well preserved, capturing the delicate details of these ancient creatures. It's like finding a snapshot of a lost world, a glimpse into the Cambrian oceans. Think of it as a grand evolutionary experiment. Nature was trying out all sorts of new body plans, testing the limits of what was possible. Many of these designs were successful, leading to the ancestors of modern animals. Others were evolutionary dead ends, strange and wonderful creatures that vanished from the fossil record. The emergence of hard shells, for example, was a major evolutionary innovation. It provided protection from predators and allowed for the development of more complex body structures. Imagine the advantage of having a protective shell in a world teeming with new predators. This period was a time of rapid innovation, a burst of creativity in the story of life. It was a pivotal moment, a turning point that set the stage for the evolution of all the diverse life forms we see today. The Cambrian explosion was a testament to the power of evolution, a reminder that life is constantly adapting and evolving, exploring new possibilities and pushing the boundaries of what is possible. Life, once exclusively a realm of the oceans, began to make its daring move onto land. It was a momentous leap, a pivotal chapter in Earth's unfolding story. Imagine a world where the land was a barren, rocky expanse, devoid of the vibrant life we see today. The pioneers of this terrestrial frontier were plants, simple, unassuming plants like mosses and ferns, the first to brave the harsh conditions of the land. These early plants, with their ability to photosynthesize, began to transform the rocky soil, creating the first terrestrial ecosystems. Scientists believe that the first land plants likely evolved from green algae, which had already developed the ability to photosynthesize in water. These algae, gradually adapting to the drier conditions near the water's edge, eventually made the full transition to land. Fossil evidence, particularly spores and plant fragments found in ancient rocks, provides clues about this transition. Think of it as a gradual colonization, a slow and steady greening of the planet. These plants, by breaking down rocks and adding organic matter to the soil, created a foundation for other life forms to follow. They were the architects of the first terrestrial habitats. Then, animals followed. Insects, the first to venture onto land, were likely drawn by the abundance of plant life. These early insects, with their exoskeletons and ability to breathe air, were well suited to the challenges of the terrestrial environment. Imagine tiny creatures, like early millipedes and spiders, exploring this new uncharted territory. Amphibians, descendants of lobe-finned fish, were the next to make the transition. These remarkable creatures, like Tiktaalik, a transitional fossil discovered in Canada, possessed features that allowed them to move and breathe on land, but still retained their aquatic adaptations. They were the bridge between the water and the land, the pioneers of a new era. Eventually, reptiles, with their waterproof skin and ability to lay eggs on land, became fully terrestrial. They were no longer tied to water for reproduction, allowing them to explore and colonize even drier regions. The land, once a desolate, barren landscape, began to green and teem with life. Forests began to emerge, providing shelter and food for a growing diversity of animals. It was a bold step, a daring move from the safety of the sea to the challenges of the land. Scientists have used fossil evidence and comparative anatomy to reconstruct this transition. They've discovered transitional fossils like Ichthyostega, an early amphibian with both fish-like and amphibian-like features, providing crucial insights into the evolutionary journey from water to land. Imagine the challenges these early land dwellers faced: the lack of water, the intense sunlight, the changing temperatures, all presented formidable obstacles. But life, resilient and adaptable, found a way to thrive. It was a testament to the power of evolution, a reminder that life is constantly pushing boundaries and exploring new frontiers. Life for billions of years have flourished within the comforting embrace of the oceans. But a new chapter was about to begin, a daring venture onto the uncharted territory of land. Imagine a world where the land was a silent, rocky expanse, a stark contrast to the vibrant, teeming oceans. The first to brave this new frontier were plants, the unsung heroes of terrestrial life. Simple, resilient plants like mosses and ferns, the pioneers of the land. They took root in the inhospitable rocky soil, slowly transforming it, creating the very first terrestrial ecosystems. Scientists have uncovered fascinating evidence of these early plant pioneers. Fossilized spores, tiny remnants of these ancient plants, have been found in rocks dating back over 470 million years. These spores tell a story of adaptation, of plants evolving the ability to survive in the dry, harsh conditions of the land. Think of it as a gradual greening, a slow but steady transformation of the barren landscape. These plants, through their simple act of photosynthesis, began to change the very composition of the atmosphere, adding more oxygen and making the land more hospitable for other life. They were the architects of a new world. Then animals followed, drawn by the promise of food and shelter. Insects, the first terrestrial animals, were likely descendants of crustaceans, creatures that had already adapted to life in shallow, brackish waters. Imagine tiny millipedes and early spiders, their exoskeletons protecting them from the drying effects of the air, exploring this new vast landscape. One particularly fascinating discovery is the fossil of Pneumodus mummini, one of the oldest known land-dwelling arthropods, a millipede-like creature found in Scotland. It's a tangible link to those early pioneers, a glimpse into their world. Amphibians, the next wave of land dwellers, were remarkable creatures, bridging the gap between water and land. Tiktaalik, a fossil discovered in the Canadian Arctic, is a perfect example. It had features of both fish and amphibians, with sturdy fins that could support its weight on land and lungs that allowed it to breathe air. Imagine these early amphibians, their bodies still tied to water for reproduction, venturing onto land to hunt for food or escape predators. They were the pioneers of a new lifestyle, adapting to the challenges of a dual existence. Eventually, reptiles, with their tough, scaly skin and eggs that could survive on land, became fully terrestrial. They were no longer bound to water for any part of their life cycle, freeing them to explore even further inland. The land, once a desolate, barren landscape, began to transform. Forests emerged, providing shelter and a wealth of new resources. Insects buzzed through the air, and amphibians and reptiles roamed the ground. It was a bold step, a daring move from the safety of the sea to the challenges of the land, a testament to the incredible adaptability of life. The Mesozoic era dawned, a time when the Earth truly belonged to the dinosaurs. It was a period of vast landscapes, dramatic changes, and the rise of some of the most awe-inspiring creatures our planet has ever seen. Think of it as a grand, prehistoric epic unfolding across millions of years. Dinosaurs, in all their incredible diversity, roamed the Earth, from the towering sauropods, like Brachiosaurus, whose necks stretched towards the sky, to the fierce predators, like Tyrannosaurus rex, with their powerful jaws and razor-sharp teeth. These creatures dominated the land. Imagine the Brachiosaurus, its massive body casting a long shadow, browsing on the treetops of ancient forests. Scientists estimate that these giants could weigh as much as several elephants, their footsteps shaking the very ground beneath them. And then there was the Tyrannosaurus rex, a creature that has captured our imaginations for generations. Fossil discoveries, like the famous Sioux specimen, have provided invaluable insights into their anatomy and behavior. Imagine the sheer power of its bite, capable of crushing bone with incredible force. During this time, the continents were joined in a supercontinent called Pangaea. This vast landmass created a single interconnected world, allowing dinosaurs to roam freely across vast distances. Imagine the diverse habitats, from lush rainforests to arid deserts, all connected in this single immense land. Scientists have used plate tectonics, the study of the Earth's moving plates, to reconstruct the positions of the continents during the Mesozoic era. This understanding has helped us to trace the migration patterns of dinosaurs and to understand how climate and environment influenced their evolution. The world was a lush, vibrant place, a prehistoric paradise. Forests of giant ferns and towering conifers covered the land, providing food and shelter for a multitude of creatures. Imagine the sounds of this ancient world, the calls of dinosaurs, the rustling of leaves, the buzzing of insects. One fascinating story comes from the discovery of feathered dinosaurs. Fossils like Archaeopteryx, a transitional fossil between dinosaurs and birds, have shown that many dinosaurs had feathers, not just scales. This discovery has revolutionized our understanding of dinosaur evolution and the origins of birds. Imagine the Earth shaking with the footsteps of these giants. The sheer scale of their presence, the diversity of their forms, the wonder of their existence. It was a time when the Earth truly belonged to the dinosaurs. It was a period of incredible life, a testament to the power of evolution to create magnificent and awe-inspiring creatures. But the long and glorious reign of the dinosaurs came to an abrupt, devastating end. It was a cosmic event, a sudden and catastrophic turning point that would forever alter the course of life on Earth. A massive asteroid, a celestial projectile of immense size and speed, struck our planet, triggering a global catastrophe. Imagine the scene. A fiery object hurtling through the atmosphere, a blazing streak of light that grew larger and brighter with each passing second. The impact, near what is now the Yucatan Peninsula in Mexico, was like a titanic explosion, releasing energy equivalent to billions of atomic bombs. Scientists have pinpointed the location of this impact using evidence like the Chicxulub crater, a massive buried structure that reveals the sheer force of the collision. They've also found a layer of iridium, a rare element common in asteroids, deposited worldwide at the geological boundary marking the end of the Cretaceous period. The impact caused a chain reaction of devastating events. A massive shock wave ripped through the atmosphere, triggering earthquakes, tsunamis, and volcanic eruptions. Debris was ejected into space, some of it falling back to Earth as fiery meteorites, igniting widespread wildfires. Imagine the sky filled with falling debris, the air thick with ash and smoke, blotting out the sun. The world plunged into darkness, a prolonged period of global winter that lasted for months, if not years. Photosynthesis, the lifeblood of plants, was severely disrupted, leading to widespread starvation. The impact caused widespread extinctions, wiping out not just the dinosaurs, but also a significant portion of marine and terrestrial life. It was a mass extinction event, one of the most severe in Earth's history. Fossils reveal a sharp decline in biodiversity at this boundary, a stark reminder of the devastation. One fascinating story comes from the study of fossilized pollen. Scientists have analyzed pollen records across the Cretaceous-Paleogene boundary, revealing a dramatic shift in plant life. Ferns, known for their ability to thrive after disturbances, became dominant, indicating a world recovering from a catastrophic event. This event, though devastating, cleared the way for a new chapter in Earth's story. It was a reset, a turning point that would lead to the rise of mammals, small, adaptable mammals, which had been living in the shadows of the dinosaurs, now found themselves with new opportunities. Imagine these small, furry creatures, once relegated to nocturnal niches, now venturing out into a world devoid of their giant rivals. It was a time of opportunity, a chance for mammals to diversify and fill the ecological roles left vacant by the dinosaurs. It was a dramatic shift, a cosmic reset that reshaped the destiny of life on Earth. It was a reminder that even the most dominant species can be vulnerable to the forces of nature, and that even in the face of destruction, life finds a way to persist and evolve. In the aftermath of the dinosaurs' dramatic departure, a new chapter began, a time of quiet expansion and remarkable diversification. Mammals, once small and hidden, living in the shadows of the giants, began to thrive. It was as if a hidden potential had been unleashed, a new era of life unfolding. Imagine these early mammals, survivors of the cataclysm, venturing out into a world suddenly devoid of their massive rivals. They were adaptable creatures, possessing traits that allowed them to survive the harsh conditions following the asteroid impact. They diversified rapidly, evolving into a wide range of forms, from tiny rodents scurrying through the undergrowth to massive whales navigating the vast oceans. Mammals filled the ecological niches left vacant by the dinosaurs. Scientists have used fossil records and genetic analysis to trace the evolutionary history of mammals. They've discovered transitional fossils like Indohuus, an ancient deer-like mammal that provides clues about the evolution of whales. These fossils reveal the gradual transformation of land-dwelling mammals into aquatic giants. Imagine the Indohuus, a small herbivorous mammal, spending more and more time in water, eventually leading to the evolution of the first whales. It's a remarkable story of adaptation, a testament to the power of natural selection. Among these diverse mammals were our distant ancestors, the primates. They were small, agile creatures, navigating the forests and grasslands, their keen senses and grasping hands allowing them to thrive in arboreal environments. One fascinating story comes from the study of Purgatorius, one of the oldest known primates. Fossil evidence suggests that Purgatorius was a small squirrel-like creature living in the Paleocene epoch, shortly after the dinosaur extinction. It's a glimpse into the early days of primate evolution, a time when our ancestors were just beginning their journey. Imagine these early primates, leaping from branch to branch, their large eyes providing them with excellent vision in the dense forests. They were skilled climbers, adept at navigating the complex canopy. It was a time of quiet expansion, a gradual filling of the niches left vacant by the dinosaurs. Mammals were not just surviving, they were flourishing, exploring new possibilities and adapting to new environments. Scientists have also used comparative anatomy to study the evolution of primate traits, like the development of stereoscopic vision and grasping hands. These traits, which allowed primates to excel in arboreal environments, would eventually play a crucial role in the evolution of humans. Imagine the world gradually changing, the forests and grasslands becoming home to a growing diversity of mammals, including our primate ancestors. It was a time of opportunity, a time when the seeds of human evolution were being sown, a testament to the resilience and adaptability of life. And then, after millions of years of evolution, a new kind of creature appeared. Humans, our ancestors, Homo sapiens, emerged from the primate lineage, a culmination of a long and intricate evolutionary journey. It was a pivotal moment, a turning point that would forever alter the course of Earth's history. Imagine our early ancestors venturing out from the forests and grasslands of Africa, their upright posture freeing their hands for new tasks. They were not just another species. They were a species with a unique set of abilities, a spark of ingenuity that set them apart. One of the defining characteristics of early humans was their ability to use tools. Simple stone tools, like hand axes and scrapers, allowed them to hunt more effectively, to process food, and to create shelters. Imagine these early humans carefully crafting their tools, using their intelligence to overcome the challenges of their environment. Archaeological discoveries, like the Oldowan stone tools found in Tanzania, have provided tangible evidence of this early tool use. These tools, some of the oldest artifacts ever discovered, tell a story of innovation. Another crucial development was the control of fire. Fire provided warmth, protection from predators, and the ability to cook food, making it easier to digest and providing more energy. Imagine the first campfires, flickering flames illuminating the night, bringing communities together. Scientists have found evidence of controlled fire use in archaeological sites, like the Gesher Beno Yaakov site in Israel, dating back hundreds of thousands of years. This discovery suggests that early humans were not just using fire opportunistically, but were actively managing it. And then there was language, the ability to communicate complex ideas and share knowledge. Imagine the first conversations, the passing down of stories and traditions, the building of social bonds. Language allowed humans to cooperate on a scale never before seen, to organize hunts, to plan migrations, and to transmit knowledge across generations. Studies of fossil skulls and brain casts have provided insights into the evolution of language capabilities. The development of Broca's area and Wernicke's area, regions of the brain associated with language, suggests a gradual increase in cognitive complexity. These abilities, tool use, fire control, and language, allowed humans to adapt to diverse environments and to spread across the globe. From the savannas of Africa to the icy tundras of the north, humans ventured into new territories, overcoming challenges and establishing settlements. Imagine early humans migrating across continents, adapting to different climates and landscapes, using their ingenuity to survive. It was a remarkable journey, a testament to the adaptability of our species. It was a new kind of force, a species that could shape its own destiny. Humans were not just reacting to their environment, they were actively changing it, transforming landscapes and building civilizations. Scientists have used genetic analysis and archaeological evidence to trace the migrations of early humans, revealing a complex network of movements and interactions. This research has shed light on the origins of different populations and the spread of human culture. It was a pivotal moment in Earth's history, a turning point that would lead to the rise of civilizations and the profound impact of humans on the planet. It was a story of intelligence, innovation, and the power of human potential. And so we arrived at the dawn of humanity. From the vast tapestry of life, a species emerged, one with an insatiable curiosity and a remarkable capacity for innovation. Humans formed societies, built cities, and developed agriculture. Imagine the first settlements, small clusters of dwellings growing into bustling centers of trade and culture. Did you know that the ancient city of Jericho, in what is now Palestine, is considered one of the oldest continuously inhabited cities in the world, dating back nearly 11,000 years? We transformed landscapes, built monuments, and created art. Think of the pyramids of Egypt, marvels of engineering built with astonishing precision. Or consider the cave paintings of Lascaux, where early humans depicted the animals they shared their world with, a testament to their artistic expression. These early creations reveal a deep connection to their surroundings and a desire to leave a lasting mark. Then the Industrial Revolution arrived, bringing about rapid technological advancements. Steam engines, electricity, and mass production transformed our lives, reshaping industries and connecting the world in new ways. But this era also led to environmental challenges. The burning of fossil fuels released vast amounts of carbon dioxide into the atmosphere, setting in motion changes that continue to affect our planet today. Did you know that the concentration of atmospheric CO2 has increased by nearly 50% since the start of the Industrial Revolution? We became a dominant force, capable of altering the very fabric of our planet. We built vast networks of roads and railways, dammed rivers, and cleared forests. We harnessed the power of the atom and sent humans to the moon. It was a time of unprecedented change, a rapid acceleration in the pace of Earth's story. In just a few centuries, we altered the planet in ways that rivaled the forces of nature themselves. We now face the challenge of understanding and managing this power, ensuring a sustainable future for ourselves and the countless other species that share our home. Today, we stand at a critical juncture. The decisions we make now will echo through millennia. We have the power to protect our planet, nurturing its delicate balance, or to damage it beyond repair, leaving a legacy of devastation. Climate change, with its rising sea levels and extreme weather events, is a pressing challenge. Did you know that the last 7 years have been the warmest on record globally? This rapid warming is a stark reminder of the urgency of our situation. Pollution, from the plastics choking our oceans to the smog clouding our cities, threatens the health of ecosystems and our own well-being. Consider this: an estimated 8 million metric tons of plastic enter our oceans each year, impacting marine life and potentially entering our food chain. Deforestation, the clearing of forests for agriculture and development, is another critical issue. Forests are vital carbon sinks, absorbing vast amounts of carbon dioxide. Did you know that the Amazon rainforest, often called the lungs of the planet, has lost a significant portion of its coverage in recent decades, impacting global climate patterns? But we also have the knowledge and the tools to create a sustainable future. Renewable energy sources like solar and wind power are becoming increasingly efficient and affordable. We are developing innovative technologies to reduce waste and clean up pollution. And importantly, there is a growing global awareness of the need for change. It's a moment of reflection, a time to consider our role in the ongoing story of Earth. We are not just passive observers, we are active participants, shaping the future of our planet. The choices we make today, from the way we consume resources to the policies we support, will determine the kind of world we leave for future generations. This is our moment to choose wisely, to embrace our responsibility, and to write a new chapter in Earth's story, one of harmony and sustainability. There is hope, even amidst the challenges. A powerful wave of positive change is building. Around the world, people are working tirelessly to protect our planet, from local communities to global organizations. A collective spirit of stewardship is emerging. Renewable energy, once a niche concept, is now a mainstream solution. Did you know that in some regions, solar and wind power are now cheaper than traditional fossil fuels? This shift is not just an environmental win, but also an economic one. Conservation efforts are also making significant strides. Marine protected areas, like the Great Barrier Reef, are being expanded to safeguard vital ecosystems. Consider this: the concept of rewilding, restoring natural processes to damaged landscapes, is gaining traction, with projects showing remarkable success in bringing back biodiversity. For example, wolves reintroduced to Yellowstone National Park have helped restore the park's ecological balance. Sustainable practices are becoming increasingly integrated into our daily lives, from reducing single-use plastics to embracing plant-based diets. Small changes are adding up to a big impact. Did you know that many cities are implementing innovative urban farming initiatives, growing food locally and reducing their carbon footprint? Vertical farms, for instance, use significantly less water and land than traditional agriculture. We are learning to live in harmony with nature, to respect the delicate balance of life. Indigenous communities, with their deep understanding of ecological systems, are playing a crucial role in conservation efforts. Their traditional knowledge, passed down through generations, offers invaluable insights into sustainable living. It's a collective effort, a shared responsibility to safeguard our home. From scientists and activists to everyday citizens, everyone has a role to play. By embracing sustainable practices, supporting conservation efforts, and advocating for change, we can create a brighter future for our planet. It is a journey of collaboration, a testament to the power of human ingenuity and our deep connection to the Earth. And together we can ensure that the story of Earth continues, a story of resilience, beauty, and enduring life. The journey of Earth is a story of resilience, a testament to the enduring power of life to adapt and thrive through unimaginable changes. From the fiery birth of our planet to the delicate dance of ecosystems, Earth's history is a masterclass in survival. Did you know that extremophiles, organisms that live in extreme environments like deep-sea vents or acidic hot springs, demonstrate the incredible adaptability of life? These remarkable creatures show us that life can find a way, even in the harshest conditions. It's a story of transformation, a constant cycle of creation and renewal. Continents drift, mountains rise and erode, and life evolves in countless forms. Consider the concept of plate tectonics, the slow but powerful movement of Earth's crust that has shaped our planet's landscapes over billions of years. Did you know that the Himalayas, the world's highest mountain range, are still growing as the Indian tectonic plate continues to collide with the Eurasian plate? And above all, it's a story of interconnectedness. Every living thing, from the smallest microbe to the largest whale, plays a vital role in the intricate web of life. Ecosystems are delicate balances where every element is connected. Did you know that the health of coral reefs, often called the rainforests of the sea, is crucial for the survival of countless marine species, and that they also provide vital protection for coastal communities? It's a story that reminds us of the wonder and beauty of our planet. From the vast expanse of the cosmos to the intricate details of a single leaf, Earth is a masterpiece of natural artistry. Let us cherish this home and work together to ensure its future. Let us remember that we are part of this grand narrative and that our actions have consequences that ripple through time. By embracing sustainability, promoting conservation, and fostering a deep respect for nature, we can contribute to a brighter future for all. Thank you for joining me on this journey. It is a journey that continues, a story that unfolds with each passing moment, and it is a story in which we all have a part to play.